Hello guys, welcome to RA Structural Hub. In today's video, I'll walk you through the process of determining the loadings on beam FB12 here, as shown in the skits partial floor framing plan. And this drawing is extracted from our previous project, and I would like to share with you determining how to determine the loads on the beam FB12 and determine also the maximum deflections due to this loading. So this calculation based on the real site condition from our previous project, where the clients made modification in this area here for functional purposes. So let's dive into the problem. Here on this design load criteria, we are given the finishes 33 PSF. The hollow core slab is a precast slab, 120 pounds per square foot, and density of concrete is given as 150 pounds per cubic foot. The size of beam 16 by 26, and the floor live load is 50 pounds per square foot. The strength of concrete is 4 KSI. So if you take a section here just to show you how it looks like, the relation of hollow core slab and the solid slab is look like this. This hollow core slab is rested on the beam, the ledge beam. The width of the ledge is 6 inches. And the height is 14 inches. So this precast hollow core slab just rested on the beam. So they bring this to the site, then laid it directly to the floor through the leads in both beams. We have also the leads in here. So let's check the solid slab here, whether it is a one-way or two-way load distribution. So our criteria here is if the length to width ratio is more than 2, we consider it as a one-way load distribution. So in our case, it's a one-way. So let us go ahead to determine the unit dead load due to the solid slab in here, 6 inches. Slab 6 inches divided by 12 and multiply it by 150, the density of concrete, that would give us 75 pounds per square foot. Then the finishes is 33 pounds per square foot. Tributary width of solid slab is 10 divided by 2, that would give us 5 feet, and it's 10 is actually coming from here. That's the width of the slab. So since it is a one-way, half of that will transfer to that beam. Then the uniform dead load, just combine this 75 slab, and the finishes is 33 pounds per square foot. And we have 75 plus 33 is to 5. That would give us 540 pounds per foot. That's a uniform load due to the solid slab. So the next one is we'll determine the contributory load coming from the hollow core slab. So we have the 120 pounds per square feet, 33 pounds per square feet, and the tributary width is 20 divided by 2. That will give us 10 feet. This 20 is here is 20. So half of that will transfer to that beam. Then the uniform dead load is a total of this 120 and 33, and multiply that total by 10. That will give us 1530 pounds per foot. So next, determine the self weight of the beam. The self weight of the beam. So the self weight of the beam, you need to consider also the beam here, including the leads. So the beam is 150. Our beam size is 16 by 26 divided by 144. That would give us 433.3 pounds per foot. So if you look at these sections, we have this beam here, and we have the leads 6 inches by 14. That is 6 by 14. So multiply that by 150. That would give us 87.7. So the total of these two items, the leads and the beam, is 520.8 pounds per foot. Now the total uniform dead load on beam is the combination of the solid slab, 6 inches solid slab, the hollow core slab, and the self-weight. So we have here a slab, the hollow core slab plus the self-weight of the beam. So if you sum it up, that would give us 2590.8 pounds per foot. That is only for dead load alone. The next one is to determine the live load on the beam. So we are given a live load of 50 pounds per square foot. Then multiply that by 10 plus 20. 10 plus 20 here in the plan. Just simply divide by 2. That would give us 750 pounds per foot. So the next one is to determine the total load, combined dead load plus live load. That would give us dead load plus live load. 2590.8 plus 750 is coming from this one here, 25 plus the live load 750. So the total is 3340.8 pounds per foot. That is the uniform dead load and live load, combination of two. So we have already determined the loading of beams, the service load of the beam. The next one is to calculate the maximum deflection of the beam. So since this is the free body diagram of our beam, simply supported beam with a span of 30 feet, and we have this loading, dead load plus live load. The formula for maximum dead load, maximum deflections is 5 times the W loads times the L over port, earth to the port, which is this one, all over 384 EI. So we have to calculate the moment of inertia of the beam, which is BH cube over 12. So our beam is 16 times height is 26 cube divided by 12. That will give us this value. So the next one is the modulus of elasticity of concrete. So this formula, you can check this formula here in the ACI code 318 section 19.2.2.1b. You will see there this formula. And the length of the beam, here we have to take note that 30 feet, you need to convert it into inches, because sometimes we get some mistake. We forgot to convert it in inches. Then the next one is the live load, the loadings should be converted to inches as well. So since this is a pounds per foot, you need to divide it by 12 that will give us 278.4. Normally we got these mistakes in sometimes in the board exam. We forgot to convert it into inches, so we have to take note on that. So plug it in our formula. The actual immediate deflection is 0.721. On this project, we have the allowable deflection criteria, which is limited to L over 360. So 360, the span of the beam, which is this one here, and that is equal to 1, which is less than to our actual deflection. So generally our beams is okay. So guys, if you found this video helpful, please don't forget to like and subscribe. Your support means a lot. It helps me create more content like this and support aspiring engineers who are eager to learn and grow to their field. Thanks for watching, and I'll see you next time. Bye bye.